Welcome everyone to this webinar that we are calling Barriers to Product Experimentation, hosted by us from Signific together with Eppo. I will be one of your speakers today. My name is Max and I'm one of the co-founders of Signific. We're a consultancy company within data in Stockholm, Sweden. And previous to that, I've been having data roles at companies like SVT, the Swedish public television company, Voi, a scooter company, and now at a music sound tech startup in Stockholm called Chroma. And together with me, I have Che from Eppo, and I'll let you introduce yourself.
Yeah, hey everyone, my name is Che. I'm the CEO at Eppo. We're a next-gen EV experimentation platform. Previously, I was a data scientist at a bunch of growth companies. Probably most of my time was spent at Airbnb. I was the fourth data scientist there. Spent about 5 years and saw a lot of that growth journey play out. So we'll be drawing on a lot of these stories as we talk about the pitfalls today.
Che, do you want to take it away with an intro?
Absolutely. So I think we're all here because we kind of believe A/B testing is important. Like we all understand that you really need to understand what works, what doesn't, why, and what investments are driving ROI. We'll start by taking a little bit of a trip down history lane here. As I mentioned before, my formative career was at Airbnb. And when we built experimentation, it was a huge mess, right? We had a lot of data, the sort of internet volume of data you see today. And the tools to compute were all these open source distributed clusters that we had to self-manage, Hadoop, Pig, and Hive. We're all extremely fortunate in that we now live in the world of the modern data stack, where pretty much everywhere you go, you see people with these hyper elastic, performant cloud data warehouses like Snowflake, Redshift, BigQuery, and transformation layer on top like dbt. And with that, you can scale experimentation much earlier on. You don't have to be these sort of megacorps to run really great experimentation programs. So most recently, I was at Webflow, which was a Series A company at the time, and we were running all sorts of experiments. And the reasons you do it are pretty clear for anyone who's been in this business, right? The thing that experimentation shows you really clearly is that all of these products that you're shipping that you think are really great, it turns out only a third or less of them are actually moving metrics in a positive direction. And that it's actually quite likely that another third is going the opposite direction and moving it negatively. So in this sort of success rate, it's like 20-30% success rate has been corroborated all over the place. There are papers out of Microsoft, Google, LinkedIn, Yahoo, Airbnb, Netflix. I can say confidently most of our clients see a similar success rate. So once you know that, once you're aware of just the actual low success rate of product, you can't really compete in a world where your competitors know what is happening and you don't. And to give a little bit of flavor of just how hard it is to predict winners, predict product winners, I have a couple stories from Airbnb. The first one is a story I love telling. It's, so I was at Airbnb for 5 years, 2012 to 2017. And during that time, by far and away, the most impactful product that shipped was this one change that made it so when you click on an Airbnb listing, it opens it in a new tab. So that one little change had more bookings impact than a bunch of multi-quarter projects, a bunch of huge investments. And the reason it wasn't like that before is just the design team didn't like it. They thought it was sort of ugly. But once you have experimentation, you can find something that every other company finds out, which is that big changes can come from, big metric movements can come from small changes. So that's big net number one. It's very hard to tell that something as simple as that would be so impactful. Big net number two is, I don't know if anyone's paying attention to Airbnb around 2012 or so, but right around when I joined, the company did a bunch of product marketing, a bunch of pounding the table for this new product called neighborhood guides. The idea was, suppose you're staying in San Francisco and you want to stay in a Mission District, you'd have this 15-page glossy description of what to do in the Mission District, where to stay, where to get pastries, where to spend time. And it turns out that another top 5 most impactful experiment we ever ran was to get rid of that product entirely, just remove it completely. And the reason was that when you come to Airbnb, we want you to book something. And once you start going down the rabbit hole of reading pages and pages of stuff, then your coffee is done, your kids start yelling, something comes up and you're distracted and then you never end up booking. Again, very hard to predict. I promise you, the whole company thought neighborhood guides was going to be a huge hit, but experimentation showed that it's not a fit for our business model. So even though it's gotten a lot easier to run experiments, it's still there's a lot of barriers to run into. And so we're going to be talking about them today.
We'll start off by Che will give an introduction to what an experimentation system is, and then go through 4 common barriers that we have seen, both from our perspective working with a lot of the front runners in Sweden and Stockholm, but also from the perspective of the international giants from Che as well. Different barriers we've seen and how to get over them.
So first thing, what are we even talking about when we talk about an experimentation platform and experimentation infrastructure? So here are all the pieces of it. These are the pieces of basically every single experimentation system in the world. You have some way to randomize users into groups, usually handled by a feature flagging system. You have some way to model and govern your metrics. So these are all the things you care about in a business, from revenue, purchases, to signups, or whatever else. These things get combined to calculate a bunch of quantities for your experiment. Things like your mean, your variance, the stuff that's going to plug into your confidence intervals. And then with these stats, you have to do a bunch of things, right? So most people, I think, know you have to run a statistical test and figure out whether one thing is significantly outperforming another. But you also have to check a bunch of diagnostics. There's a bunch of failure modes of experimentation, from biased randomization to faulty data to bugs in the product. And so you really don't want to lose a bunch of time not realizing that there's a failure until the very end. You want to catch it quite early on. So automated diagnostics is a big part. And then I always say it's pretty rare that you run an experiment and you just move on with your life. People always want to dig deeper and figure out what is going on. So investigations are actually a core part of this entire workflow. People want to figure out, okay, maybe it was neutral overall, but was there some segments that had outperformance or an underperformance that could explain everything? And we saw those situations all the time here, maybe. A situation where it was generally a positive result, but it was deeply negative on Internet Explorer or something because there was a bug there. Or it's generally positive, but it was deeply negative in East Asia because we messed up time zones. All of this stuff gets rolled up into reporting because experimentation is a very public process. Everyone collaborates on it, PMs, designers, engineers. It's not something that's kind of wholly owned and operated on in the corner by some handful of technical users. It's very much part of the cultural fabric of the company. So these are all the pieces that you have to get right. I often say, experimentation, it's not that there's any one particular hard problem. It's a large pile of medium-sized problems that all have to orchestrate properly. And this all kind of adds up to this sort of flywheel. The idea is, you start running a bit of experiments, you do perhaps do it maybe manually, maybe a bit more slowly, but it gets people interested in running experiments, and then that drives a lot more investment in the infra. And then eventually you get to a point where you have something like an Airbnb system where it can go really fast. Running experiments does not take much effort. People may or may not have seen this sort of paradigm, but I'll add to my commentary to this. One is when I see these sort of A/B testing flywheels saying first you have to do stuff very manually, onerously before you can have good infra. That feels like a bit of a learned behavior. As we'll see with Eppo and other tools, you can actually start off right away with something that will make experimentation go very fast and be very trustworthy. And the other thing that I really love about experimentation is that because it's such a public process, because it's such a kingmaker, it decides what products are successful, which weren't. It will actually drive investment on your entire data ecosystem. Your investments in tools like Fivetran and DBT, your data quality tools, the extra data engineer headcount to make sure your data is good. Once you are putting it out there that certain products work and certain products don't according to metrics, people are going to want that data quickly. They're going to want it to be trustworthy. It'll drive a lot of your data ecosystem. So the first barrier, these all-in-one tools that promise the world but cannot integrate with your data infrastructure. So the problem we see, and this is a big part of Eppo's founding story, is that a lot of these old school experimentation tools, they can only use these sort of shallow click-through metrics. They can't really use the sort of analytics infrastructure you see in the modern data stack in Snowflake, BigQuery, Redshift. The sort of stuff that the whole business is operating on. Instead, you not only have to use kind of lower stakes metrics, like a top of funnel click through, even that data is probably wrong in some way because it's different than the data the rest of the company is operating on. They essentially create parallel warehouses. So, to get the flywheel moving, to get people to care, the first barrier to overcome is to actually use a metric that people are going to care about. This is the main designation I see. In the world of companies, there are business metrics, things like revenue, activation, purchases, stuff that whole teams are gold on. And then there are these sort of upstream shallow metrics like a sign up. And there's also varying degrees of quality. Are you using a business metric to a level of precision that your BI tools use? Or are you using some proxy event that is 10% incorrect because that's the only thing your experiment infra will use? So the shortest answer I can give here is to say the best thing that the internal tools that Airbnb and Netflix provided was the ability to use metrics that the CFO would care about, that your finance org would sit up and notice with positive experiment, things like bookings, etc. And all of these types of important business metrics live in your warehouses, in your Snowflake, or they are coming out of Stripe, which again is only available in your Snowflake. Use metrics that CFO cares about. That's a much better way to get investment into your experiment culture, rather than saying, hey, I boosted click conversions or something like that. To give you a sense of why I say this is a pattern we saw all the time at Airbnb. I pulled this from one of our blog posts from back in the day. If anyone remembers Airbnb 2012 to 2014 or so, this is before Instant Book took over everything. Back then, you had to search on Airbnb, then you had to contact the host and say, hey, I'm interested in staying, will you accept me? And then that host had to accept you, and then you had a booking. And so you had these kind of stages of the conversion funnel. And we saw this pattern over and over. It was probably the most common pattern we saw, is that an experiment would inflect one part of the funnel and downflect the other part. You'd go up earlier and then down later, or vice versa. And so whenever you're running these experiments that only care about a top of funnel action, it's quite likely you're going to be seeing some pattern like this if you actually measure all the way down the funnel. And again, I would say this is by far the most common result we saw over and over from tens, hundreds of search ranking experiments and search page experiments. Important to check down funnel. So what are your options here? You can commit engineering resources to try to get business metrics into an Optimizely or something like that. But I think any user of those tools has kind of seen how much of a maintenance headache that becomes, but it is an option. And you're committing kind of precious engine resources that should go towards core products. So instead, actually, what I see most often, and it's the kind of state of the art today, is most people will purchase some experimentation tool or build an in-house feature flagging thing, and then they'll start DIYing analysis in Jupyter Notebooks and Looker. And so they'll kind of embrace that analysis is going to be a very manual process, but it'll use the right data, it'll use the downstream metrics. It's just that now I have to scale my data headcount by experiment velocity, which becomes very expensive very quickly. And especially if you go notebook route, you suddenly have 200 notebooks, all with slightly different choices on experiment analysis. So as you might expect, here at Eppo, we believe that you should be able to get a best-in-class tool, a sort of Airbnb class tool, but have it just natively operate off the data warehouse. Not require engineer resources, have near zero integration costs. In my 100% biased opinion, this is, I think, the direction the industry is going.
So on to barrier number 2, and a bit relating to what you said there, Che, of course, around that we spend too much time cleaning up the data. So why that takes time is the business metrics Che talked about. It requires, in many cases, several data sources. You both have your Stripe and payment data at one place, CRM, different apps, different websites, different points of data sources that you want to connect in order to get to these business metrics. And then also to do a statistical analysis, this requires data at a certain level of granularity in order to work with this. And this is not a super trivial case in task in many cases, and something that takes a lot of time and stops companies. This goes back to the experimentation system, essentially, before going into doing sufficient stats. It's both sides of the randomization and the assignment of experiments, and also the metrics. And here data integrations really matter, because we need trusted and auditable metrics in order to get to the point of sufficient stats and then take the experimentation culture forward. As Che mentioned, a lot has been done here with the cloud data warehouses and on the transformation side with the modern data stack. But still, this, in many cases, to my experience and the companies we work with, this is still a very time-consuming area. And why is that? If we look at the kind of building blocks in order to do a good statistical analysis and evaluate your experiments, you have, for one, the different assignments. So what users are part of our assignments. And in order to know if a user were assigned to variant A or B at a certain point in time, you need to have that kind of granularity of what experiment for what users at what timestamp or at what time that happen. And on the other hand, we have our facts or our events that we want to evaluate the experiment on. And same approach here. We want it on a level where we have the user ID, the different events or actions, and to map that to the timestamp of when a user were part of a certain experiment. This can be quite a straightforward joining of different data sets. I'll get into that. We don't always have the data as structured as this in many cases, but It usually is a fairly simple join, but a very big one, quite computationally heavy, and you kind of need to understand and be quite careful and know a lot about the data in order to get to this point where I can have the assignments and map that to the right events and users. But then, as Che mentioned earlier, also in many cases we want to do diagnostics and dive deeper in our analysis of our experiments. So what dimensions or what factors do we want to use when analyzing, which makes it a bit even more complex. We want to map, okay, what kind of browsers did the users use that were part of this experiment? Were they on a paid plan or a free plan, or any other dimension that you might think about might be relevant for a specific experiment? And again, mapping this to the timestamp and to the users and to the sessions usually is where you want to take your data modeling and in order to do a good analysis of your experiment. But doing this from scratch for every experiment and putting data scientists to do this all the time, it does not really scale. It takes too much time, and it will block you from analyzing more experiments and eventually becoming a more learning organization. So what can you do instead? First off, Che has already talked about that, but utilizing the data warehouses support several sources of data, but also have the data available at a certain granular level. But then there's also, it's not only about loading the data and having it available. We have seen this movement the last years from ETL to ELT, which basically is to make a transformation of the data once it's in the data warehouse, to set up a flexible analytical data modeling and transformation in order to save time, not do it over and over again, and have a better data model that's easier for analysts and scientists and tools to integrate. And this is also something that you continuously improve. How can we make this more effective? How can we make the data more with better quality? It's not something you get right from the first time. So see this as a continuous improvement and a huge time saver if you can get the data modeling right. And one proven approach, there are many, kind of how you want to model your data, similar to my example there with the assignments and the fact tables. A proven approach is a star schema modeling, a data model optimized for analytical queries. It's fairly intuitive to navigate. We have dimensions relating to events, and it's fairly easy to set up and kind of mimic different user journeys, different business processes to your data, which makes it a lot easier. But essentially, regardless of your model, you want this cohesive structured data model that's easy to work with and that we can reuse different tables, different dimensions, and work a bit more flexible rather than doing it from scratch all the time is kind of the key takeaway here. This is something that we at Signific have been talking about before, and if you want a deep dive in this topic, I encourage you to look at our webinars. But with that said, I'm handing over the mic back to you, Che, on barrier 3.
So the other big barrier is that you end up needing a lot of data scientists to run experiments. And a big part of the reason, I alluded to it before, there's a lot of small failure modes of experiments. And a lot of them come down to kind of what you're trying to do here, which is make decisions. Make decisions on what products are moving metrics in the ways you want, which ones are not. And an easy way to think about this is to say, when you run these experiments, what are you doing to your false positive and false negative rates? Every single outcome, there's whether this experiment is actually moving metrics in good or bad directions, and whether you end up believing that's moving in good or bad directions. And there's a bunch of situations in which you believe it's good, but it's actually bad, which is a false positive. You end up launching this thing, it turns out it was moving metrics in the wrong direction, or it's actually good, but you don't think it's good because of a variety of reasons you get into. And so this is kind of a lost opportunity. You spent all the time building the thing and put it out there, but you never got to actually validate that it's a good product. There's a bunch of examples of this. Honestly too many for one webinar, but I'm going to give you some of the most common ones. The one that is super, super common, especially the way most tools present results to you, is peaking. Problem with stopping experiments early. So as a bit of background, most experiment practices are using these things called t-tests or Bayesian methods. So both most standard Bayesian methods and t-tests fall into a class of tests called fixed sample size tests. They kind of go with this assumption that you're going to not look at your results until it's done, until all the data has been gathered. And as most people who have worked in an organization know, that's a pretty unrealistic assumption. People look at these results early and often, and honestly, for pretty good reasons. If it's broken, you don't want to waste weeks. And that just leads to a lot of possibilities where people get overexcited or over negative and just want to stop things early. This type of problem leads to a lot of false positives because, as an example, if you look at p-values over time or treatment effects over time, they fluctuate so much, and actually the probability that a p-value is going to end up below 0.05 at some point in the test is actually fairly high. If you are stopping experiments early with a fixed sample size test, you'll end up somewhere around like 25-30% false positives. A bunch of the tests that you think are good are not actually good. So there's some pretty good solutions here. One of them is the process thing. Is you somehow put the guardrails around the results and make sure no one makes any decisions until they're done. But the result we like here, Eppo, is a method called sequential analysis. So this is something that has existed in academia for a while and now is in kind of becoming standard in commercial tools and in-house tools. But the idea is sequential analysis says, let's just assume you're going to look at results every single day. Let's assume you're continuously monitoring it. And we're just going to adjust the p-value thresholds to make up for that. So the cool thing about it is if the results are green, then you can just make a decision and not worry about your false positive rates. So another one of the things built into Eppo, we of course give you the option if you want to use t-test or Bayesian method. Other most common issue we see is gathering too little data, not powering your test sufficiently. And this is a big issue because if you need a month and a half of data and you only wait a week, then there's a lot of wasted effort because a bunch of ideas that are actually good are not going to show up as good. You'll get a lot of false negatives. Oddly enough, you might also end up with a high ratio of false positives too, because anything that does show up as positive in that 1 week is more likely to be spurious noise than the actual product effect. This is really common, and a big part of the issue is that running power analyses is a pain, as we'll show, but it is very necessary. So you need to do a power analysis to figure out how long do I need to wait to get enough signal to make a call. So if anyone has seen Evan's awesome AV tools, Evan Miller's online calculator, here's a typical power analysis. You put in kind of your baseline effects and then some sort of minimum detectable effects. And from there, you get some output of saying how many people in the experiment do you need. And then that'll give you some guidance of how long to wait. Now, a big part of the problem is if you're doing an in-house DIY solution, you're kind of crossing between these online calculators and your kind of in-house analysis. Tools like Eppo build power analysis in as a first-class citizen. You get these progress bars in so that you always know how far along are you. And then the third kind of pitfall is, honestly, it can be just very hard to get enough data, to get enough signal. Not everyone has Airbnb scale, and so getting a sufficient volume is a tough negotiation with the org. There is some kind of harsh truth to this. Like, if you're like an early stage startup and you just don't have that sort of volume to run an experiment, then there is only so much you can do about it. But I do want to point out that there are things you can do about it. And it comes again from the world of stats. There's a method called Qubit. And I love talking about Qubit because it's exactly an example of what we aim to achieve here at Eppo, which is bring the sort of capabilities you see at an Airbnb or Netflix to the commercial landscape. So what Qubit does is, you can think of it like denoising headphones. It takes a bunch of the ambient noise around you and cancels it out so that you can hone in on the actual product effect. To give you an idea of it, 100% of experiments at Airbnb use Qubit. 100% of experiments at Netflix use Qubit. Like it's very mainstream and standard in things, but it's never been offered commercially until Eppo did it. To give you an idea of how it works, suppose you were McDonald's and you were running an experiment to improve the number of Happy Meals being sold. A normal approach would be to say, let's run this experiment, count up the number of Happy Meals on two groups. The Qubit approach would be to say, every time someone walks into a store, let's make an intelligent guess on whether or not they're going to buy a Happy Meal. For example, if you are a family and you have 3 kids, it's quite likely you're going to buy a Happy Meal. If you are 2 hungover 20-somethings, it's not very likely that you're going to buy a Happy Meal. Most powerfully, if you've purchased Happy Meals in the past 30, 60 days, then it's quite likely you're going to purchase another Happy Meal. And so it turns out, if you make these guesses, you include all this kind of ambient predictive stuff in your analysis, then you can get experiments that would say take a month and a half to only take a month. You save 2 weeks. We've seen improvements all the way up to 50, 60%, for experiments with power users. So it's powerful stuff, and it saves you weeks of product time. Now, Eppo is the first commercial tool to offer it. For anyone who's curious, under the hood, it's actually fairly straightforward. It's a linear regression that's happening off of all of these predictors. And again, a lot of the times, the most predictive thing is how many purchases or transactions or whatever happened in the previous 30 days. And then one last pitfall. Who here has heard of Nassim Taleb's Black Swan? I kind of, even though Nassim Taleb is a bit of a character, I love that he wrote a book about this because I'm guessing in most of people's businesses on this webinar, you have a big outlier problem. It turns out that any sort of socially networked company naturally ends up with these like huge outliers that can drive the entire experiment. So to give you an idea, at Airbnb, we had these hosts that we used to call whale hosts. And these whale hosts were not your mom and pop, with a extra bedroom or extra house. This was a full-on property management corporation running thousands and thousands of Airbnbs on the site. And if you were not careful, just some random chance sorting of these whale hosts in the experiment will actually drive the entire effect. At Webflow, we had a similar thing where there were some website creators who were, again, large corporations, not individuals, and they were creating huge amounts of activity. So I now believe that most companies actually have outlier issues, and you need to be wary of it because they'll be invisible. Most experiment results are not going to show you this. So these black swan outliers, what can you do about it? There's a few things. So one is you can use winsorization. So the idea is take your distribution of users, take the 99th percentile of the value, and kind of clip everything above it. So it maxes out with the 99th percentile. That's something that we offer out of the box at Eppo. Another is to use threshold metrics. So instead of just counting total revenue, count the percent of people who had over $100 of revenue or something like that. Again, out of the box at Eppo. And then Cupid, which I just mentioned, actually does a huge amount for outliers. And the reason is that if you are a whale host on Airbnb, you were probably a whale host before the experiment started. So this sort of denoising technique of saying, like, let's look at your history and kind of take that out of the experiment effect will actually do quite a lot to mitigate outliers. These are kind of the three main methods. And, I would guess that most experiment practices out there are sneakily being driven in different directions by hidden outliers that we're not getting to link. So very important. So a lot of things you have to do. Like I said, a bunch of medium-sized problems that all have to work in orchestration. You got to use stat tests properly, not peak too early. You have to run power analyses to guide how long to run things. Ideally, you use methods like Cupid so that you save weeks of time, and then you got to handle your outliers with, one way or another. Winsorization and Cupid being kind of our preferred approach. So I mentioned before, a lot of big tech companies have built these sort of internal tools that bring these all together. There's a lot of great blog posts coming out of Airbnb, Netflix, DoorDash. We're excited to finally bridge that with the commercial world. And what else can you do? Besides using tools like Eppo, a lot of it is just knowledge sharing and upskilling. The experimentation community it's kind of it's small, but it's tight knit. There's a lot of communities you can reach out to on LinkedIn, a lot of reading material, again, put out by DoorDash, Netflix. There's Coursera classes. You can try to learn a lot of the shape of these statistical methods and also learn data engineering practices to try to get there. Or you can use a lot of these next-gen tools that kind of give you a lot of these effects out of the box.
The fourth and last barrier, the lack of organizational trust. So let's say we can evaluate our experiments on business metrics. We have made the data much more accessible and easier to work with, and we have upped our stats games. We know about the pitfalls Che just went through. Guess we're all good to go then. Well, scaling an experimentation culture is not only about the statistics and the data, it's also about how we work together as a company and really changing the culture to become a more learning organization, to our experience in many cases. But what's stopping organizations to do that? So when working with experimentation, it's in many companies still, it's quite a new thing. It might not be in the way we've done product here at this company before. It might be something that a certain part of business or sales or other parts of the organization is not used to. And new things always comes with a lot of friction. And it can also be quite complex. What you saw, what Che went through, how we talked about the data and the data stack and how you need to get the data to a certain point. You have the significance, the hypothesis, the confidence interval. For people who are not familiar with this, it can feel quite complex to my experience when starting to kind of get more people on board this train. And another stopping factor is also that it can be perceived as costly. Che went through it in the beginning, that it's kind of needed to have this experimentation approach when finding the right product, especially if your competitors use it. But it can be a discussion to have there when we have built something, we had it in the backlog and in the roadmap for quite some months, now we build it. Why should we invest time in making an A/B test in order to learn this? Why can't we just ship it and learn the next time, or a similar approach? But this is kind of different areas that you go up against, so to say, when getting the whole company on board this experimentation culture. And there are a couple of things. There's a lot of things you can do to solve this. I'll go through three. So one is kind of thinking about the right level of abstraction when you're talking to people who are not statisticians or data scientists, and also sharing this across the company. And then the transparency around when you're uncertain. It's quite a big leap to work in a data-driven way and trust the data wholeheartedly. You can still be uncertain in many cases, and the transparency around that. And then kind of thinking about how we go from learning to testing to learning to win. So if we take these three, starting with the right level of abstraction, what we want to get at is that we want more people to see the benefits of using experiments, having this as a natural way of doing product development, doing business development, and creating value for our users. And in order to get there, I think one good approach that we've seen both at SVT, I've been part of it at Voi and different companies, is focusing more on the learnings rather than teaching stats. Today we have gone through a bit into detail on different statistical pitfalls, but talking about p-values and the statistics details to people who aren't familiar with it and perhaps not that interested is not usually the right approach. Focus on the learnings rather. And then also thinking about the user experience when you come to the reporting state. How do we guide users to clearly understand what the result is from an experiment, and how do we guide users to do the analysis themselves? So we're not dependent on a data scientist all the time. We kind of need to guide users or internal users to that. And then when it comes to metrics, being quite consistent with the metrics to avoid cherry picking, that, okay, this worked in this sense. What are the actual goal of this hypothesis? Did we move the metrics we wanted? And be quite consistent, and in some case opinionated on what metrics you choose. And I'll go through some examples. So when talking about abstraction levels, kind of going from this, your Jupyter notebooks and perhaps complex visualizations of different results from an A/B test, which actually creates a barrier towards the organization to kind of understand what's going on, how can we make use of this in our daily work. And instead moving to something more like this. And I can understand this might seem a bit complex at the get-go. This is an evaluation we did at SVT of an A/B test of a bunch of different variants. Looking through it when you present it and when you work with data like this, to have a prioritized list of metrics. I know it's quite small right now, but there's metrics there that everybody understands, and we have a clear division of what's more important than others for this very experiment. And then using guiding elements to make it easier for people to understand. Is this significant? Is this an uplift or a downlift? Is this better than other variants? It's usually a better approach to kind of get people on board this experimentation train. Under the hood of this, there's a lot of stats, a lot of math, a lot of data, but kind of adding that abstraction layer is usually a good way to go. Another example of this, to even more focusing on the learning, this is a template we used at SVT, how we shared the kind of evaluation of each experiment we did. So having both the hypothesis at the top, but also some description of what experiment have we run, what was the expected effect, and what have we learned from that experiment, the key resulting key summary of the learning, and also the next steps and action. You're going to take your reporting to this level and kind of the knowledge sharing to this level, rather than the more complex Jupyter notebooks, I think is a better approach in many organizations to get it going. But it can also be about the toolings you choose, and something like this. This is a screenshot from Eppo. We have been using Eppo with some of our clients, and I'm really impressed with what you're building. Hence, we hosted this webinar together. But again, also going back to the example I gave from SVT there, with having a clear prioritized list of metrics. You see there what's the primary metric when you evaluate a certain experiment here. Guidance to both investigate, but also quite clearly guide users to see, okay, this was the results, the different uplifts, the difference between different variants. Kind of guiding users towards that, where you want to take it to a state where a product manager can do this with perhaps limited statistic knowledge, but still make the right evaluation and the right call from your experiment data. And to do that, adding some level of abstraction. Under the hood, it's these complex numbers. You should know them. You should have good understanding of your data. But adding this kind of layer is usually something that helps kind of making it easier for people to trust experiments and foster that culture. But then the second part, transparency around uncertainty. So making decisions on data is not easy. When we say we want to be data-driven, now we're going to let data guide our decisions. Even as analysts and data scientists, in many cases, we face uncertainties from the results we get from data. And that can be for many reasons. Perhaps the most common one is having bad data. Even it's either wrong, it's not enough, it's too complex to put together. Usually a common reason for analysts and data scientists to not feel comfortable in communicating the results we get from the data, and also for companies in general to believe in the results we get from experiments. And even if you have a pretty good understanding of your data, in some cases you don't have clear winners. It might be this experiment was proven to improve a certain part of the funnel, but not the next one. What should we do around this? How should we make a clear decision out of this experiment data we have? And even if you find a winner, your experiment seems to have a proven effect, there's still other aspects to take into consideration, such as a novelty effect that users start clicking on something new, or a seasonality that it works during winter time but not during the summer. A bunch of different effects that can cause uncertainty. So what can you do when you kind of find yourself in this situation where I'm not really sure about the result, I'm not really sure how we should, I'm not really sure if I can trust what the data scientists say or what I present as a data scientist? The main thing is don't hide that uncertainty. Be transparent about that. This is indications. We might want to follow this up. We might want to dig deeper within this area, because the opposite of that is kind of getting bitten afterwards, when you kind of realize that after quite some time that this wasn't true, and then you kind of lose the momentum of the trust within the organization to use experimentation, and you kind of need to start over again. So my recommendation would be to be a bit upfront and don't hide the uncertainty if you see it, and also making the unclear data visible. This is something we need to solve. It's not something that we should end up deciding not to do more experiments. We should solve the bad data problems we have and make that visible. And Eppo is a great tool for doing that, but there's also other ways to communicate around data, working closely with the data engineering team, working closely with the products team if you're an experimentation lead, for example. As a data scientist or an experimentation lead, it can usually help a lot to coach the process early on, to kind of guide the teams in both, is this a hypothesis and experiment design that we will get clear results from? Do we have the tracking set up in a way that we can get data in the way we need it and evaluate the way we want? So kind of moving towards coaching as early as on before we have launched the experiments. And there are a bunch of different hacks or different tactics to reduce this uncertainty. Che talked about power analysis to ensure we'll have enough data. Another one is doing AA test, essentially just splitting your users, but giving them the same thing, ensuring that the configuration is right, looking into an area which is might not seem that problematic. You split users into 50-50, but in reality, that's not always the case, and that can have quite big consequences. So make sure that you have balanced groups when you evaluate it. We talked about not stopping experiments too early. It's also about catching kind of the novelty effect, that it might be good in the beginning, but does this effect hold over time? Seasonality, one way of reducing the risk and uncertainty around that is to enforce a process where we do follow-up tests. Okay, this worked during the winter time. Let's follow this up a few months later. Do we see the same result? If this is a crucial learning we get from this test. And another one is doing code or analytics reviews, similar to what software engineers do to kind of review their code. Kind of, this is an analysis I made just to catch errors and also share knowledge within the organization. All in all, things that reduce uncertainty, but you'll still face it, so don't hide it. And the last one is a quote that I really like from Elena Verna. She's at Reforge, previously headed up growth at SurveyMonkey, who says that first you must learn to test, then you learn to learn, and then you learn to win. So essentially going back to this flywheel, having the approach of iterating, learning, and improving. There are tools that can, and the different tactics, as we have gone through today, that can make it faster to go around this flywheel, but you won't get it right the first time, most likely, if you're starting out. So it's very much an iterative process where you try to capture the learnings both from the experiments, but also the process itself, and improving over time. Because when you get to the point where it's easy to do experiments and you learn quickly and you learn quicker than your competitors, that's where you want to get at. So that was our 4 barriers. I'll do a quick summary and then we'll open up or I'll send it over to you then later, Che. But so the all-in-one tools are not flexible enough. Move towards a more modern experimentation system is kind of the main takeaway there, I would say. Too much time spent cleaning up data, invest in the data modeling and analytics engineering, so you don't have to start over from scratch every time you do an analysis, in order to get away from the dependency of having a data scientist always available for every experiment. Invest in tooling and knowledge sharing to democratize the statistical abilities. And lastly, the lack of organizational trust. Have a guiding and supporting approach where you are transparent and accessible in the way we want to get more people on board on the experimentation train. So that was that. But I also want to hand over now to you, Che, to briefly talk about Eppo.
As we mentioned, we're Eppo. I call ourselves experimentation for the bottom data stack. So we focus a lot on data integrations. Making sure that we're using the highest quality data and using it with like very rigorous methods and stats. I won't talk through all the stuff, but here's some kind of general shape of our company, built by alums of Airbnb, Snowflake, and a bunch of other great experimentation cultures like Uber, Stitch Fix, Pinterest, and others. We have a bunch of customers, large and small, some of the largest data volumes in the world, and some of the fastest growing companies in the world, venture backed, and so we're going to be growing. So love to chat if you're interested in upgrading your experiment infra.
Thanks a lot for listening in. And if you want to talk more experimentation, feel free to reach out to me or Che on either LinkedIn or email. We're happy to talk experimentation anytime or anything data, so don't hesitate. And if you would like to get notified on coming webinars from Signific events we have mainly in Stockholm, articles or stuff we want to share, we have a newsletter. It's maximum 2 emails, probably less than that per month, and I promise you no spam. I'll share a link to that if you want to sign up. Other than that, thanks a lot again, and we open up for some Q&A. One question coming up, classic one. How does Eppo handle PII-based KPI calculation? There is some stigma of sending PII over American-based cloud services due to GDPR.
Yeah, I love that question. So we have a great take on it, which is that we don't egress data out of your system until it's aggregated. So we're called a warehouse native application. So all you do is you create a user for Eppo in your warehouse. It's like you just hired a new employee. Employee's name is Eppo, and you provide us SQL queries. And we're going to stitch those SQL queries together and ship them out to your cloud. So you have full auditability of every query we're running. You can see exactly what we're doing. You can shut us off at any time, and there's no PII leaving your system. The only thing that we pull in is like the aggregate that in this experiment there were 10,000 users who did 1,000 purchases or whatever. That's the only thing we pull into our system. So it's very, very friendly to anyone who has kind of GDPR restrictions or generally cares a lot about privacy. Thank you for asking that.